Hi, welcome to astronomy. This is the introduction to basic astronomy, introductory notes. So, again, we talked about this a little bit in class. The word month literally comes from the word month, meaning new moon to new moon, which is about 29 and a half days for us to see new moon to new moon. Remember, the moon orbits the Earth every 27 and a third days, but because the Earth moves about a degree around the sun, in order for the moon to come back to new moon phase, it has to continue to go around the Earth a little bit more to line up. And that's called syzygy when all three things are lined up. So when three planetary objects line up, syzygy. Down in the asterisk below it says moon needs about 2 days extra to catch up to be in line. So what that means is, okay, wrong picture. Anyway, this is the picture of the celestial sphere. It's like you look up and you can see directly above you is up, and then everything on the horizon, your head's looking down, like there's a bowl over your head, like a sphere. So everything we see, we call that the celestial sphere. And this shows the ecliptic pole, or what's right directly above us. And then has some stars named up there, like Deneb, Vega, and Altair, or the summer triangle. So this is a good picture of us in the summer. And there's Sirius. I talked about that in class as well. It's the dog star, the biggest, brightest star in Canis Major, big dog constellation. Here in North America, it is our brightest star we see. And because it's so close, yet so far, it looks like an airplane up there. The red, blue, out of phase. The red and blues come out of phase because it's so far, but again, because it's so close, it's pretty bright. Okay, so this shows a full moon, and then as the Earth from the top to the bottom location of the Earth orbits the sun, the moon might go 360 degrees around, but it has to go a little bit further around to get lined back up for full moon phase again. And again, here's a picture a good friend of mine took, who's a professional photographer, of the solar eclipse in August 2017. And he put this together. I just thought they're really great pictures. All right, the moon moves 12 degrees a day across the orbit. So how do we know that? Because it takes the moon 29 and a half days to go around the Earth. The full circle is 360 degrees, so we simply divide 360 by the number of days. Then we realize, oh, the moon moves about 12 degrees a day. And you'll notice that. You're going to measure that and look at it, watch the moon move across. So a new moon to new moon is considered one synodic month. We don't base our months upon new moon anymore because it really threw the calendar out of whack. We were having summer and winter. But anyway, the new moon to new moon is called a synodic month. Syn sounds like sun, so you see it's lined up with the sun. One complete 360-degree orbit around the Earth is called a sidereal month because it's a real orbit. Sidereal and synodic month explained up here. You can see the synodic month is when the moon has to get back in line with the sun and the Earth, so it takes a couple extra days to line back up. Whereas a sidereal month, it just has to go 360 degrees around. The moon phases, make sure you know these because I will put something like this on the test and ask you to label these phases. So if we start at new moon, where you can't really see the moon, it always waxes or gets brighter from what we see the right side. Now if it's rising, that right side is going to be the bottom side. When it's up at its highest point, that's going to be the right side. And when it seems to be, oh, you know what? I take that back. The moon will rise as we orbit in the east. So the waxing, the bright parts can be on the right, which would be on top. And then when it sets in the west, the waxing will be on the bottom. It'll be bright on the bottom. First quarter, because we see a quarter of the moon. So a quarter of the moon we see lit up, even though half the moon is really lit up. And then you have waxing gibbous, waxing getting brighter, and gibbous means more than half what we see is lit up. Then, of course, the full moon, when everything of the moon that we can see is lit up. So we're pretty much in line with the sun. And then there's a waning gibbous. Waning means to get weaker or lighter. So it's getting darker, getting weaker in light. So it's getting dimmer and dimmer. So waning gibbous. Then you got your last quarter, which is getting dimmer. Then the waning crescent, where it's just going back to new moon phase again. And then new moon. So wax gets brighter, wane gets dimmer. Wax on, wane off. When measuring the motions in the sky, we use two terms. That young lady there is holding a professional type of sextant. We're going to make a cheap one out of a protractor. We use declination. So the sky wheel you're going to build in class has the word declination on it. That's measured in degrees. That's the angle of the objects from the Earth's equator to the North Pole. Not from the horizon we see it on, but from the Earth's equator. If you shoot the Earth's equator straight up to the sky, 0-degree declination would be right over the equator. 90-degree declination would be directly over our North Pole. Every star directly overhead the equator is at 0 degrees declination, kind of like latitude lines. So declination is like latitude. It's good to know. Right ascension is kind of like the time zone. Location of the object going across our equator as the Earth turns. Since it takes the Earth 24 hours to turn on its axis, right ascension is measured in hours, minutes, and seconds. It measures east to west like longitude lines across the horizon. So right ascension is like longitude. Again, anytime you see anything bolded, big, and red like that, chances are it's going to be at least a fill-in-the-blank question, if not something to be explained. Okay, here it shows you in the picture. I love pictures, 1,000 words. North celestial pole, directly above our North Pole. Declination is angle above where you can see that plane shoots out, the imaginary plane shooting out from the equator. And right ascension is going across around the time zones, as with longitude. Okay, here we have the twins, Castor and Pollux, the Gemini twins. So if people would see the stars up there, they didn't have a whole lot of lights back then or a whole lot of electricity and games to play at night. It's kind of hard to keep the fires going, to keep it bright enough to play stuff. So they'd sit around and look at the stars a lot, and they came up with stories based upon connecting the dots in the sky, making constellations. So as you can see these stars, when they came up, when you get darker areas and you can see them more, people draw little lines together and say, oh, look, let me tell you the story about these twins, the Gemini twins. So the Gemini twins are Castor and Pollux as the heads of the twins, stars, Castor and Pollux. Boom. Ooh. A galaxy is simply a collection of millions to billions of stars several thousand light years away from us. Our own galaxy, Milky Way galaxy, is loaded with tons and tons, millions of stars. It is about 200 light years thin. That's from the short way going across it to thousands of light years across. That means traveling the speed of light. You wouldn't get there your lifetime. So a galaxy, collection of billions of stars. A lunar eclipse is when the sun's light is eclipsed by our Earth. And the lunar eclipse will never be totally black because the Earth's atmosphere contains a lot of water. Water will bend and diffract the sun's light, and the orange and reddish waves are longer light waves, and they'll hit the moon. The shorter waves will get diffracted more, like the blue, and they'll get scattered. So why is our sky blue? Because we have an atmosphere. As the sun comes through our sky, those blue waves get diffracted and they fill the sky with blue. The moon does not have a blue sky. It has just a black sky. You saw the pictures from the moon because it doesn't have an atmosphere. It's got a very tenuous, very thin atmosphere, not enough to scatter any light or breathe. So it doesn't have a blue sky. Anatomy of lunar eclipse. You've got When the moon is in the total Earth's shadow, not counting the bent light through the atmosphere, but when it's in the total, that's called umbra, like an umbrella. When it's partially in the shadow, throw the word partial in there, now it's a partial umbrella or penumbra. So you can see the umbra on a solar eclipse when the moon gets between the sun. Last year, we experienced the solar eclipse, and we were actually in the umbra here in St. Louis. So for a few minutes, or about a minute and a half, and up in here in St. Louis, South County, we saw darkness come over the day in the middle of the day because the umbra fell right over top of us. We've experienced a lot of partial solar eclipses in the penumbra, where you take your little pinhole viewer out there and you can look at the shadow and you can see, hey, part of the sun is being blocked by the moon, but not all of it. So again, umbra, total blockage; penumbra, partial eclipse. Umbra, again, is like the umbrella. The penumbra is partial. Okay, the bottom right picture shows the moon coming between us and the sun. And during the umbra phase, the sun, the photosphere of the sun is totally blocked out. Now you can see the corona. It's a very thin, big atmosphere shooting out there. That corona's got that light pearly glow to it. Okay, zenith is the key vocab term you guys need to learn and use in everyday language when you're talking astronomy. It means the highest point in the sky, a celestial point, any celestial sphere goes. Our sun, for example, it will never get directly overhead of us in St. Louis. So its zenith is what we call solar noon, when the sun reaches its highest point in the sky. And because we're in the northern hemisphere, the sun will always, always, always be south of directly above us if we're standing up straight. That's why south windows, south facing buildings get sunlight, and a lot of it, especially in the winter. North facing windows, not much sunlight, hardly gets there except for reflective sunlight, and shade plants grow better there. So it's good to know astronomy if you want to design a house for passive solar heat if you're gardening. So the astronomical horizon is what we call straight across. The true horizon is a little bit lower because we do stand a little bit above the Earth. It's curved. This is over exaggerated here, but and the zenith is the highest point in the sky. All right, so you can see the zenith directly above us. The meridian is the path it takes. When the sun gets its highest point in the sky, it goes over 23.5 degrees, and that would be down in Florida. So if you're in Florida on June 21st, then you'd probably cast no shadow, as long as you're low down the lower part of the panhandle. In the winter, the sun's path, December 21st, is very low, and it beats far into windows, which gives us some extra added heat. Okay, a solar day is measured from solar noon to solar noon, and we call that exactly about 24 hours. It works out very well. A sidereal day is measured from the stars. Our Earth turns 360 degrees on its axis to get back to the sun, or back to the stars rather, but it turns about 361 degrees to get back to the sun because it's traveled an extra 1 degree orbiting the sun. So the sidereal day is slightly shorter than 24 hours because it takes its 360-degree angle in less than 24 hours. It takes that extra 1 degree movement to get back to being in line with the sun again. So a distant star way out there, as Earth, the arrow on my right, I did this in paint, so it's cheap. But as the Earth is rotating, or sorry, orbiting around the sun, it's going from the bottom part, bottom blue ball, up to the top blue ball. It's made a 360 degree where the line is pointing at the distant star. Pretend that distant star is like miles away in this drawing, not inches. that would make those lines more parallel, like a 360